Okay, now let's talk about section 2.2, graphs of equations. In two variables. And intercepts. Symmetry. In section 4.5, we mentioned the concept intercepts. At that moment, we tried to sketch the graph of a parabola, the quadratic equation. We need that intercept. But here, actually, that is a section 4.5. It's after this section. Just because that's about the inequality, so we put it together with the inequality of involving the opposite value functions. So that's the reason we left it earlier. But now we will systematically study intercepts and symmetries. Okay, so equation first, graph equations by plotting points. So an equation in two variables. Two variable, you can say st, uw, uv, whatever, but here let's say xy is a statement in which two expressions involving x and y are equal. Okay, so if you have two expressions on the left hand side and the right hand side of equality, of the equal sign means the equal, so that's called an equation in two variables. Okay, so you can see that, for example, x squared plus y squared to 5, or y is 2x plus 5, or x squared is equal to y. All these statements are equations in two variables. Okay, so first we get the equation in two variables. And second, the graph of an equation in two variables consists of the set of points in the xy plane whose coordinate xy is ordered pair, satisfy the equation. Okay, so that's the definition. Then let's explain what it means. So a graph is a set of the points in the xy plane, and the points satisfy this condition. The coordinates of the point satisfy the equation. What does it mean? The coordinates satisfy the equation. For example, let's pick up x squared plus y squared is equal to 5. If we have a point, its coordinate is 1, 2. Let's check. X is 1, y is 2. So 1 squared plus 2 squared is 1 plus 4. It is exactly 5. So we say the 1, 2 satisfy the equation. X squared plus y squared equal to 5. And then the point P is in the graph. x squared plus y squared equal to 5. If you can collect all the possible p, and then you will have the complete graph. Okay, so that's what a graph means. So in order to determine the point on the graph or not, on the graph, not in the graph. In order to determine if the point is on the graph or not, you just check if the x, y coordinates satisfy the equation or not. So let's see. Determine if the following points are on the graph of the equation 2x minus y equal to 6. Okay, so the first point is 2, 3. Well, let's just examine, check. 2 times 2, so 2 times 2 minus 3. 2 times 2 is 4, 4 minus 3 is equal to 1. Okay, it's not equal to 6. We check the left hand side, and we see it's not equal to the right hand side. So the point 2, 3 is not on the graph. Okay, that's the first verification. Second one is 2, negative 2. 2, negative 2, let's check. So 2 times 2 minus y is negative 2, so minus negative 2. So 2 times 2 is 4, minus negative 2 is plus 2, that's 6. Good. So the point 2, negative 2 is on the graph. Okay, so this is on the graph. This point is on the graph. The first point is not on the graph. Okay, so the point on or off the graph totally depend on the if this coordinates satisfy the equation or not. Okay, so second example, we graph an equation by plotting point. Actually, whenever you see plotting the point, it's a job of the computer. It's not our human handwriting job. It's just a computer job. So we use this simple function to demonstrate how we do it. So graph the equation y equal to 2x plus 5. How to plot? We just pick up the possible value of x and try to determine the y coordinate. Okay, so we choose x as 0. When x is 0, you compute 2 times 0 plus 5 is 5. Then you pick up next one, possibly, let's see, x is 1, y is 2 times negative 1 plus 5, 3. X is negative 1, 1, 7. X is negative 1, this is a 3. Let's make it bigger. X is 10, 2 times 10 plus 5, 25. Okay, so you get those x and the corresponding y coordinate, y value. Then x is 0, y is 5. X is 1, y is 7. X is negative 1, y is 3. X is 10, y is 25. Well, possibly I cannot sketch it at 10. It's too big. 25 is too big. So let's check 0, 1, and negative 1. 0, 5. Wow, it's already very large. let's assume this is 5. 1. At 1 it's a 7. Someplace. At -1 it's a 3. 7, 3, something like this. And then, if you believe me, I mean you have to trust me. If you have more sample point of x, you can find the corresponding sample point of y. You get enough plotting point, you will see that the graph of this function is a straight line. This depends on a big amount of computation, a big amount of sample. Okay, so the equation, the graph of the equation y equal to 2x plus 5 is a straight line. Okay, another example. Y equal to x squared. Y equal to x squared, we are going to do the similar sample. X is 0, y is 0. X is 1, y is 1. X is 2, y is 4. X is -1. I mean, how do I get it? I just put it here. Evaluate the function at 1, 2, and 0. And when x is -1, -1 squared is still 1. When x is -2, -2 squared is 4. So let's just pick up 1, 2, -1, -2, 1, 2, 3, 4. When x is 0, so the point 0, 0, 1, 1, 2, 4, -1, 1, -2, 4. 0, 0 is here, 1, 1 is here, 2, 4 is here. So just try to connect them with a smooth curve. And here's -1 is equal to 1. -2 is also equal to 4. So just try to. Okay, so with a more supporting sample point, you can get this graph of y equal to x squared. It's called a parabola. Okay, again, this is just an idea how to graph an equation by plotting point. It's really a job of a computer. It's not human being job. Okay? That's a thing. So how to get those sample points? You get x value, you compute y value. Get x value, you compute y value. And you put them as xy coordinates. And this process guarantees this point satisfy the equation. Okay, so second, find the intercept. From a graph. Intercepts. What is the intercepts? The points, if any, at which a graph crosses or touches the coordinate axis. Are called intercepts. Okay, so whenever your function, the graph of the function cross or touches the coordinate axis, x-axis or y-axis. For example, touch. This is touch. This is cross. This is also cross. Cross means one part. There are two parts. One is on the left side, or one is on the right side, or one is above it, one is below it. Touch means the whole part is always on one side. That's a touch. And if this point is on the x-axis, this is x-intercept. If it's on the y-axis, it's a y-intercept. Okay, if it's on the x-intercept, if it's on the y, it's y-intercept. And the example is the following. Assume you have the graph like this. It could be very, well, I just try to get, assume this is a graph of certain equation. Assume that we have the graph of some equation. And then let's see. This point, assume this is -3. This point, assume this is a 3. This is a 3/2. It's a -4/3. And the -3.5. And this is a 4.5. Okay, assume you have those values. Then we can see that then on the x-axis, when we talk about the point, that's this point, but when we talk about intercepts, it's just a coordinate. So the -3, 3/2, 4.5 are x-intercept. And y, for the y, it's on the y-axis. 3, -3/4/3, and -3.5 are y-intercept. On the x-axis, x-intercept. On the y-axis, y-intercept. Okay? So that's the definition. What is a x-intercept and what is y-intercept? And if you know the graph, you just check where is the intersection point of the graph with the x-axis and the y-axis, and that's it. Sometimes you have the equation, but you don't have the graph. If you have a graph, a lot of things can be done. But if you have only equation, possibly you need some effort. So find intercepts from an equation. Find the intercepts from the equation. You see here, let's just check this. If you have x-intercepts, they are on the x-axis. On the x-axis, all points have y-coordinate 0. On x-axis, because when you project it to the x-axis, y, there's no height. You're on the floor, so y coordinate 0. On the y-axis, all points have x coordinate 0. On the y-axis, it's not on the right, it's not on the left. On the right, positive, on the left, negative. On the y-axis, x coordinate is 0. Okay, so when you have an equation, if you set y coordinate equal to 0, you will get x-intercept. If you set for an equation, let y be 0, solve it, you find x-intercept. Okay, let y be 0, solve it, you find x-intercept. let x be 0. Solve it. You find y-intercept. Okay, so that's the strategy and idea to find the corresponding intercept based on the equation, not the graph. Okay, let's check. Example. We have a graph. We have the equation y equal to x squared minus 4. Y equal to x squared minus 4. Find x-intercept. Find the x-intercept, y is 0. Y is 0. Y is 0, so y here is 0 equal to x squared minus 4. So x squared is equal to 4, so x is plus minus 2. Let's write this way. We have 2 and negative 2. So there are two x-intercept. Then find the y-intercept. For y-intercept, x is 0. X is 0, so y is 0 squared minus 4, so y is negative 4. There, so here this graph has one y-intercept, has two x-intercept. One y-intercept, two x-intercept. Okay. So that's the intercept. Intercept and is very important when we try to sketch the graph, not plot. Plot is not smart because plot depend on the evaluation again, repeatedly infinitely many times. But if we know some property, we can quickly sketch the graph. Okay, so another property for the graph of equation is something called symmetry. Symmetry with respect to x-axis, y-axis, the origin. Okay, so let's first see the geometry and then we go back to the algebra. With respect to x-axis, so we have this piece, this piece. These two shapes are symmetric with respect to x-axis. It means if you fold the page along this line x-axis, those two pieces coincide. So this is symmetry. With respect to x-axis. With respect to x-axis. And then let's check. You have a point here. You have a point here. This point, they share the same x coordinate. So here you have x. Here you have x. One is above x-axis. The other one is below the x-axis. So if this top part is y, the bottom part will be negative y. Okay? So they are symmetric with respect to the floor. One is on the floor. The other one is below the floor. Okay? So that's a xy, x negative y, the reason. The definition. A graph is symmetric with respect to the x-axis if for any point, for every point xy on the graph, the point x negative y is also on the graph. So symmetric, you must have the image. So this is a point on the top, then its image with respect to this axis will be also on the graph. Then this is a symmetric two piece. I mean, for this one, it has two pieces. And that's a reason you see those x, y, x minus y. Here's x, y, then its image is x minus y. Okay? And for the symmetry with respect to y-axis, let's see. Y-axis, we go this way. Assume I draw something symmetric. Okay, this is a y-axis. If you get symmetric with respect to y-axis, here you have, they share the same level, height. So you have y, but one is on the right, the other one is on the left. Okay, so one is x, y, the other one is a negative x and a y. So the definition will be similar. Okay, let me write down the definition. Definition. A graph is symmetric with respect to the y-axis if for every point x, y on the graph, okay, x, y on the graph, negative x, y is also on the graph. Okay, negative x, y is also on the graph. So that's a symmetric with respect to y-axis. Right? And to memorize this definition, you just recall this picture. Next, let's see the symmetric with respect to the origin. Origin just means this way. You have this point, you have the origin. You connect them and you go opposite direction, the same positions. So this is P, this is P prime. These two things are symmetric with respect to the origin. If P has a coordinate x and y, you see here, they share the same x position, but one is on the right and the other one is on the left. So for the x, here's x, here's negative x. For the y, this y is on the top, this y is on the bottom. These two things are very identical. This part and this part, they are identical. Okay? So, what is a symmetric with respect to the origin? A graph is symmetric with respect to the origin if for every point x, y on the graph, negative x, negative y is also on the graph. Okay, just be careful about this the sentence. Let's summarize what we have in one picture. We have P here. Then if we get the symmetrical point with respect to the x-axis, this is xy. Then this symmetric image will be P1. X is same x, they are both on the right side, so the same x, but y changes. Okay? And then if you want to get the symmetric point with respect to the y-axis here, that's called P2. They are on the same height level, so y is the same. But this point, we are talking about this point. This pair is symmetric with respect to y-axis. So this is on the right side, this is on the left side. Negative x changes. And if we draw the symmetric point P3 with respect to P2 here, so they are on the same side for x, both left side. So it's negative x, the same thing. Here is negative x, here's negative x, the same side. But y changes. Here this y is on the top, this y is on the bottom. And you check here, this pair is exactly the symmetric point with respect to the origin. And also these two are symmetric with respect to the origin. Because how do we get the symmetric point? We just put a negative sign for x and y. This one, if you put a negative sign for negative x and y, you will get negative negative positive x. Negative y is negative. So these two things are symmetric with respect to the origin. And actually these two things are symmetric with respect to the y-axis. They share the same height but different sign of x. Okay? So that's what the symmetry means. So here's the comprehensive picture for all three concepts. Okay, so after the graph, after the definition, how do we know if function is symmetric with respect to x, y, or origin or not? How do we know it? There is a test for the symmetry. So the test for the symmetry. On the graph means it satisfies the equation. Okay, so symmetric with respect to x-axis. So how do we know that? We replace x by replace y by negative y in the equation. If you get an identical equation, after you replace y by negative y, you still get an identical equation. It is the symmetry works. It is symmetric with respect to x-axis. What is the example? Okay, check here. What is the example? Assume you have y squared equal to x. Assume you have y squared equal to x. And we replace y by negative y. So we get a negative y. Whenever you see y, you write a negative y. And you have square to x. Okay? And you simplify it. Negative y squared is equal to y squared. So it's y squared equal to x. Here, you do not solve equation. You just simplify the equation. Don't solve it. Okay, simplify just means a simple algebraic operation. You don't do it in the hard way, like solve it, figure out the value. No, there's no such thing. Here, negative y squared, negative sign squared is positive. So you after a simple simplification, you get y squared equal to 1. The original equation is also y squared equal to negative. Y squared is equal to 1. So you have the identical equation. It is the graph is symmetric with respect to x-axis. Okay, it is. Okay. And next, y-axis. symmetric with respect to y-axis, you just replace x by negative x in the equation. If you get an identical equation, it is symmetric with respect to y-axis. Okay, if it is. Okay, the example will be this: y equal to 4x squared over x squared plus 1. Let's just check. You whenever you see x, you write negative x. So 4 negative x squared, negative x squared, and plus 1. Don't forget the parentheses. Negative x squared is x squared. Negative x squared is x squared plus 1. You just do the simplest computation. Okay, you see y is 4x squared, x squared plus 1. Y is 4x squared, x squared plus 1. The identical. So the graph is symmetric with respect to the y-axis. Okay, it is with respect to the y-axis. And the origin. The origin, you have to combine both. You see here, origin actually, you first get symmetric about the y-axis and then about the x-axis. So you have to examine it is symmetric about the y-axis and about the x-axis, both. Replace x by negative x, y by negative y in the equation. If you still have an identical equation, it is symmetric with respect to the origin. Okay? Let's see if we have some. No, let's use our powerful example: x squared plus 4, y squared equal to 4. You replace x by negative x. You replace y by negative y. Don't forget parentheses. Negative x squared is still x squared. Negative y squared is still y squared because it's squared. So it's identical. So the graph is symmetric with respect to the origin. Okay, that's no problem. And actually from here you can see that if you have even power, here is a square, 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 all the places. That's just simplest even number. If you have an even power, then you possibly will have symmetry, right? Even power 2, 4, 6, the negative sign will not change the value. So you have even power for y, it's symmetric with respect to x-axis. If you have even power for x, it's symmetric with respect to the y-axis. If you have even power for both, it's symmetric with respect to the origin. Okay. Anyway, to memorize what value you are going to replace, you just recall this photo picture. Here, this is about x-axis. You are going to replace y by negative 1. Here is a symmetric about the y-axis. You are going to replace x by negative x. Verify this point is on the graph or not. Okay, so this picture is important. What's next? The next is a graphing equation by finding intercept, checking symmetry, and plotting. Okay, so let's see the simple example. Know how to graph key equations. What are the key equations? First, y equal to x cubed. Y equal to x cubed, you check that if you replace x by negative x, then negative x cubed is negative quantity x cubed. And this expression, you see, what you have is this one, y is equal to negative x cubed. The original equation is y equal to positive x cubed. They are totally different. So the function is not symmetric. The graph is not symmetric with respect to y-axis. With respect to y-axis, you change x is with respect to y-axis. Similarly, replace y by negative y. If you only change y to be negative, so it's negative y x cubed. Nothing changes, so the graph is not symmetric with respect to x-axis. Okay? Well, if we replace x by negative x, y by negative y, we got, you see, negative y is negative y, x is negative x, and negative x quantity cubed, it is negative x cubed. Here you have product, the 3 negative 1 is still negative. And the 2 negative signs, they cancel each other. So you get y is equal to x cubed. This is exactly the original equation. So the graph is symmetric with respect to the origin. Right? It is symmetric with respect to the origin. Y equal to x squared. Y equal to x squared, we already plotted before. So it's a parabola. It looks like this. And this is y equal to x squared. If you want to sketch x is equal to y squared, you just change x, y row, x, y coordinate. So you will have something like this. You see, you switch the order. This is x, this is y. You just put it to the right side, so it looks like this. You change the opening from topward to rightward. Y equal to 1 over x. Let's do the problem here. Y equal to 1 over x. 1 over x, x cannot be 0. So naturally there are two parts. And 1 over x can never be 0. 1 over x is not equal to 0 because the numerator is not equal to 0. And x cannot be 0. So y has no y-intercept because x cannot be 0. And if you try to plot it, it will have two intercepts. And it has no x-intercept, no y-intercept. No x-intercept, y cannot be 0. Y is 0. 1 over x is never 0. No y-intercept, x cannot be 0. And the symmetry. What is a symmetry? Let's check. For replace x by negative x. Wrong. Not correct. Right? If you replace x by negative x, you will get y is equal to negative 1 over x. That's different, so not correct. Replace y by negative y. It's about the x-axis. Replace y by negative y. It's still not correct, because if you have a negative y 1 over x, you multiply the equation by negative 1, you get y is negative 1 over x. The same thing, so not correct. And the final thing is replace x by negative x, y by negative y. X by negative x and y by negative y. And this time y by negative y, so it's negative y. X by negative x, 1 over negative x. Those negative signs can be cancelled because one comes from left, the other one comes from the right. Cancel the negative sign. Okay, so if you use plot to compute, it's going to be, this one. It's going to be this one. We don't need to sketch it again. Yeah, it's exactly this. So that is the discussion of a section 2.2, the graphs of, let me read. The graphs of equations in two variables, intercepts and symmetry. Intercepts and the intercepts just means this is intercept. Just get the intersection with the x-axis, always the y-axis. It can touch, it can cross, whatever, either way. And symmetry. Symmetry, you memorize this picture. This is symmetry about the x-axis. This is symmetry about the y-axis, and this symmetry about the origin. And this is unified table, a unified picture for the symmetries. Okay, so those concepts are very important for us to sketch the graph of certain functions when it is easier to find the intercepts. Okay, so we finish this. Video. We will start next video to discuss a different topic. And once again, I made a short video to explain the mistake in the section 1.5, and some more examples in the section 1.6. And also, I want to thank the student Alondra. She pointed out that problem. And yeah, that's it. And again, if you have a question, ask me, send me email. If the problem is a single problem, I will work it out and send the picture to you. If it's a common problem, I will mention it in a separate video. Thank you very much. I stop this video and start another video.